This is Richmond. This is my YouTube channel, and it's for math and science only. I want to make math and science very easy here. So, if you want to learn science and math, please, this is a very good channel for you. All that you need to do is just subscribe to my channel by hitting on the red subscription button there, and then you'll be part of the group. And you can also click on the notification button up there, and then you'll be notified anytime that.
Okay, this is Richmond, and today's tutorial we are on the laws of indices. And then I'll just encourage you that nobody was born a genius and nobody was born a mathematician. Any mathematician that you've seen or every genius that you've seen say that it's about 1% genius and then 99% hard work and other stuff. So I just encourage you that if mathematics like being the hardest course or subject for you, I trust me, it can be the best course for you or the best subject for you. The only thing is that you have to put in extra effort. Okay, so with the laws of indices, we just follow the first law, and that's the law of product, the product law. All that you need to know here is that when they have the same basis, okay, the base here a raised power m, and they have a raised power n, meaning the bases are the same. So a is equal to base and then m and n, okay, equal to what we call the power or the exponent or the index. So we have exponent. Okay, so a is the base, m and n refer to the exponent. Okay, so the first law is saying that when the bases are the same but the exponents are different, what do you do? So a raised power m times a raised power n. So let's take one of the base, so you have to write one of the base here, and then we add their exponent, so m plus n. And this is what we term the first law of indices. So let's try some examples using the first law of indices and see how exactly how it works. Okay, so we have 2 raised power 2 times 2 raised power 3. And please note this, if the bases are not the same, you can apply this law. The bases should be the same before you can apply this law. So here, because the bases are the same, we take one of the bases, which is 2, and then we add the exponent, which is 2 plus 3. So you're going to get 2 raised to the power 5. Okay, so let's take another example, and then we see how we can do. So this is example 1. Let's take example 2. We have x raised power 2 times x raised power 3. Please see that this one is multiplication sign. Okay, it's a multiplication sign. So because they all have the same basis, which is x and x, we have to pick one of the bases, x, and we add the exponent 2 plus 3, which will give us x raised power 5. Very easy. Okay, let's take the last example here, and then we move on to the next law, because the laws are actually simple. So let's take example 3 here, and example 3 is 2 raised power 3 times 2 times 2 raised power 2. And I said this one earlier, that when we have a number without an exponent, we write it with an exponent of 1. So meaning that 2 without an exponent here, we can write it 2 raised power 1. Okay, so this can be written as 2 here because they all have the same basis, 2, 2, and 2. So what the first exponent here is 3, plus the exponent of 2 is 1, plus the exponent of 2 here, the last 2 is 2. Put them together, and then we have 2 raised to power 3 plus 1 is 4, and plus 2 give us 6 here. So we have 2 raised to power 6. Okay. Okay, so we are continuing from where we ended at the end. Then this was talking about the second law. And the second law of indices is just about division. So if I have something like this, a raised to power m is dividing a raised to power n. All that we need to know is that the bases are the same, and then we just have to pick one of the bases, that's a, and then we subtract the exponent. So we subtract the second exponent from the first one, so it's going to be m minus n. And note that if you this a raised to power m divided by a raised to power n can be written as a raised to power m over a raised to power n. And this one too, we solve the same way. We are going to take one of the bases, which is a, write the exponent the first one, that's a raised to power m, and we subtract the second exponent, that's n. Alright, like this. So we mean that this and this are the same. Okay, so let's take some example here and then see how we can solve it. So let's take example 1, and it is 2 raised to power 4 dividing 2 raised to power 2, like this. So 2 raised to power 4 dividing 2 raised to power 2, all we do is that let's take one of the bases, which is 2, and then what you need to do is write the first index. You write the first index notation of a number, that's 2 raised to power 4, and then we subtract the exponent of the second index from it, so it's going to be minus 2. So what I'm going to get, the base the same 2, and then 4 minus 2 will give us 2 here. Okay, so let's take another example. And then with this, all that I'm saying that if the bases are not the same, please, the law cannot be applied. So the bases should be the same if you are solving this type of question. So let's take example 2. And example 2 is the same thing here. It's like following the same method. Raised to power 6 dividing 3 raised to power 3. And then this we will get, let's replace by one base, that is 3 here. And then the exponent is 6, and we subtract the second exponent from the first exponent, going to be minus 3, and it gives us 3 raised to power 3. So I said that this is going to be the last example, but let's take another one to finish it up. And this is example 3. Let me take x raised to power 5 over x raised to power 2. And this one, all that we need to write is that write the base, which is x, and then the exponent of the first one, that is the expression on top. And then we subtract the exponent of the expression on this of the second one from it. It's going to be like this. So x raised to power 5 minus 2 is going to be x raised to the power 3 as this. So basically this is how the laws of indices, law 1 and then law 2, can be applied. So we move on to what we call the third law, and then see how we can use that one. Okay, so we are on the third law, and the third law is basically when a power is raised to another power. Like what I've written here, a raised to power m is multiplying by n. So is that this power m is multiplying another power, which is n. So to solve this question, all that you need to do is that we open it and we multiply the power by the power. Is going to get a raised to power m times n. So whenever you're dealing with the power multiplying a power, we just multiply only the exponents which are multiplying. Okay, so let's take this one and see how we can do this one. Have a, okay, you can write it here. Okay, 2 ax, then by multiplying So to solve this question, all that we need to do is that we multiply the exponent by all the exponents in the bracket. So this one is going to be ax multiplied by n, and then by multiplied by n. So this is how we solve this type of question, or this is how the third law works. So let's try and take another example and see how far we can go about this. Let's say you have 3 raised to the power 2 multiplying 2. How to solve this question? Because it's a product, a power multiplying another power. And I said if a power is multiplying another power, you multiply the exponent. Okay, so we're going to get 3 raised to the power 2 times 2, which will give us 3 raised to the power 4. Okay, so another example so that our understanding will be broadened. Okay, so let's take this one. If I have 10 raised to the power, let's say 4, and then I have another value here 5 multiplying, what actually am I going to get? It's going to be It's going to be 10 raised to the power 20, because 4 times 5 is 20. Let's take the last example on the third law, and then we will move on to the next topic. Okay, so let's check this out. If you have 4 raised to the power, let's say 2, okay, we multiply by 4 here. All that we need to do is that simple. Let's write a 4 and multiply the exponent. 2 times 4 give us 8 here. Okay, so this is how we deal with the third law, and I keep on encouraging you that you can do best if only you take some time to go through the basics and then revise everything daily. Okay, so let's meet in the next tutorial where we're talking about exponential equations, talking about indices. Okay, thank you.